All right, good afternoon, everybody. This is one another the digital math notebook reviews from what was talked about in class. This one is over understanding rational numbers. So let's get right into it. We're going to skip the do now slide and talk a little bit about slide number 4. As we said in class, this represents a Venn diagram. Remember, a Venn diagram is where you're comparing different things. In this particular example, though, it's different from the ones that you guys know. You guys are used to the two circles beside each other and knowing that this side represents everything that pertains to only the classroom learning, everything that applies to only classroom learning. On this side applies to everything that only applies to online learning, and where they overlap or cross is where they share similarities. This is similar but different in that there's no longer just areas where they cross, but there's circles inside of circles. So for example, everything inside of the purple circle for City Sugarland means that all of the purple is inside of yellow, inside of green, inside of blue. And we use real life examples to help you. We know the city of Sugarland, all of Sugarland is inside of Texas, but all of Texas is not Sugarland. Let's say that one more time. All of the city of Sugarland is inside of Texas. Every single part of Sugarland is a part of Texas, but all of Texas is not made up of Sugarland, right? There's more cities in Texas than just Sugarland. There's San Antonio, there's Houston, there's Dallas, Fort Worth, El Paso, Orange, Fort Worth. I already said that. I think there's a bunch of cities inside of Texas, not just Sugarland. Same thing. State of Texas, all of Texas is inside of the United States. But Texas is not the only state inside the United States. There's Alabama, Mississippi, New York, Pennsylvania, Wisconsin, California, 49 other states. And as well, all of the US is inside the world, but not all of the world is inside the US. So, like we said, the world has everything inside of it, but the whole world is not made up of the US, Texas, or Sugarland. The United States has Texas and Sugarland inside of it, but all of the United States is not Texas, and all of Texas is not Sugarland. Okay? So remember that idea because we're going to need that later on when we start understanding rational numbers. So our focus for today is to classify rational numbers, integers, and whole numbers using a Venn diagram. Classify rational numbers, we're about to define that. Integers, we're going to redefine that. And whole numbers, which you should remember from elementary school, using a Venn diagram. Our first blank on slide 7. Okay, first blank on slide 7. Rational numbers are all numbers that can be written as a fraction. Rational numbers are all numbers that can be written as a fraction, A over B. They are also decimals and they can be negative. They're also decimals and they can be negative. So below are some examples of rational numbers. We have 5 hundredths, negative 21 and 34 hundredths, 2 fourths, negative 12 over 16, and 5 eighths. All of these are examples of rational numbers. So now on your own, I want you to come up with 4 different rational numbers. Come up with 4 rational numbers of your own. Pause the video, write down 4 examples. So a lot of you probably wrote decimals and fractions. So my question to you would be that we do know that 2 over 4 is a rational number because it's a number that can be written as a fraction. What about if we just took the 2? I'm sorry, if we just took the 4. What if we just took the 4? Is 4 a rational number? The answer to that is going to be yes, because 4 can be written as a fraction. If we wrote 4 as a fraction, it would be 4 over 1. The reason being is that we know that fractions always represent division. Okay, every fraction problem is actually a division problem. Every fraction is actually a division problem. So it's saying 4 divided by 1. 4 divided by 1 equals 4. So you know that these two are equal. Also, that 4 can be written as a fraction, so therefore it's a rational number, not just a whole number. Also, it can be written as a decimal. If I added 4.0, okay, this is still 4. Think about it as money. This is $4. This is $4 and now 0 cents. Both of them are still the same amount. They're just written differently. So every whole number can be written as a fraction or a decimal. So therefore, as we're going to see, every whole number is actually a rational number as well. Let's go to our next example. So blank are whole numbers that are positive or negative. Our answer to this is integers. Integers are whole numbers that can be positive or negative. Integers are whole numbers that can be positive or negative. They are whole numbers and their opposites. whole numbers and their opposites. So below we see some examples of integers, and we use some examples of that number and their opposite. 4 and opposite of 4, -4. Both of these numbers are integers because they're both whole numbers, except one's positive and one's negative. And you have 12, 9, on and on. So on your own, come up with 4 examples of integers. Okay, you should be unpausing the video. So as we see again, this number 4 popped up again. As we saw, that was a rational number. It's also an integer because it is a whole number. Some other things you came up with is 3, 12, -12, -3, on and on. And then our last important vocabulary is whole numbers, okay? A whole number is an integer that is 0 or greater, okay? Whole number is an integer that is 0 or greater. Make this a little smaller. That's too small, will do. And not a fraction or a decimal. So that's to be whole. Can't be any fraction, can't be any decimals. Whole numbers cannot be negative. Okay, this part is important. Whole numbers cannot be negative. As you see, it has to be a 0 or greater than 0. Whole numbers can be 0 or greater than 0. And last, whole numbers are the counting numbers and 0. Some of you know counting numbers from elementary school. That's all that phrase means. So some examples. We see the number 4 again. 12, 972, 0, 734. You come up with 4 examples on your own. Pause the video to write down 4. Okay, so like we said, we saw 4 again. We saw it as a whole number, an integer, and a rational number. There's a thousand, well, not a thousand, there's an infinite amount of answers you guys could have put in here for 4 examples of whole numbers. Just as long as there's not a fraction or a decimal and they're not negative, your answer is correct. Okay, so now with all the information, let's go ahead and start reviewing. So like we said, whole numbers are 0 and greater. Integers are any whole number that can be positive or negative and their opposites. And a rational number is any number that can be written as a decimal. So now let's take the time to match up. Okay, we're going to drag and drop the labels. These are our labels to classify the rational numbers. So you guys do that, and then we're going to come back to it. So pause the video and place them where you think. Okay, so for some of you, you guys put whole number here for 45. Some of you put integer for -22. Also, we're going to do this one. Some people might have put integer for 0, or they might have put a rational number, or they might have put a whole number. Because similar to 45, it could have been all 3. But we're going to talk about the one that we want. So in this case, we're going to use whole numbers. So we'll talk about why in the next slide. -1 and 800ths is going to be our rational number. 3/8 is a fraction, so it's a rational number because it's not whole. -14 is a whole number, but it's negative, so it has to be an integer. 1800ths is a rational number because it's a decimal. And last is -711, which is going to be a rational number. Okay, let's go to our next slide. So now, similar to our Venn diagram from slide 4, okay? Remember how we talked about the city of Sugar Land, Texas, the United States, and then the world? Our numbers work the same way. Every whole number, as you see, similar to the Sugar Land or to the Texas example, all of the yellow is inside of green. So it means every whole number has to be an integer, but also all of the yellow is inside of blue. So that means every whole number is also going to be a rational number. That's why we have the phrase, all whole numbers are integers and rational numbers, while all integers are, oops, just messed the whole stuff up. All integers are rational numbers. But not all rational numbers are going to be integers. Not all rational numbers are going to be whole numbers. Let's look at some examples. So for example, numbers 0 and 4 are classified as whole numbers. So you see 4 in all 3 of them. While -9 is only classified as an integer and a rational number because it's negative, not positive. -500ths is a rational number because it's a fraction or a decimal, so it cannot be whole, so it's not an integer or whole number. Same thing for 3/4. When we classify these, I don't want to keep putting boxes everywhere. I'm gonna put it to where it will work for everything. So naturally, the only 4 I would need would be this whole number one. Because if I have a 4 here, that means that it's also gonna be integers, also be a rational number because The yellow circle is inside of the green and the blue ones. The yellow circle is inside the green and the blue one. So let's take a second to classify these. So we're going to do one together. Let's do 2. So 2 is a rational number because I know I can write it as a fraction or a decimal. I can write it as 2/1 or 2.00. It's also an integer because it's a whole number that's positive or negative, but it's also a whole number because it's 0 or greater as a whole. But the best place to put it is going to be as a whole number because it's inside of all of the circles. You guys classify the rest. Okay, so let's check to see what you should have. So you should have had negative 1800s as a rational number, negative 25 as an integer, negative 5400s as a rational number, 3/4 as a rational number, negative 5 is going to be an integer, negative 3/8 is going to be a rational number, 0 is going to be a whole number because it's greater than 0, it's 0 or greater than, and also therefore makes an integer and a rational number. These straight lines represent absolute value. So every time I see those straight lines, that means absolute value. Absolute value, once again, remember, absolute value, once again, is measuring our distance from 0. Remember, absolute value is measuring our distance from 0. And because of that, we know that absolute value is always positive. So the absolute value of negative 14 is positive 14, which makes it a whole number, integer, and a rational number. Now, this last one is tricky. This is here to throw you guys off, just to check to see how well you understand this. A lot of people want to put this as a rational number because they see a fraction and they say that's it. But remember, for all of these kind of questions, if we can simplify our number, we can. And we said that fractions mean what operation again? Division. Good job. Every time we see a fraction, we know that means division. So really, this is 21/7, which means the same thing as 21 divided by 7, which equals 3. Since it equals 3, I know, therefore, that I'm not going to leave it as a rational number because it's not just a rational number. It's not just an integer. In this case, it's actually a whole number. Okay? All right. You guys will work on the exit ticket on your own. And that is it for this particular lesson. Hope this helps. Have a great day.